Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than that?
$127 billion. That's how much market value Nvidia lost in a single day, not over weeks or months. In one devastating session, the semiconductor giant watched its stock crater as global markets absorbed news that would reshape the entire technology industry. The catalyst wasn't a failed product launch or a quarterly earnings miss. It was something far more fundamental, something Western experts had repeatedly declared impossible. Deep within China's tech sector, Huawei had achieved a breakthrough that shattered every assumption about America's ability to control advanced semiconductor technology. Dr. Marcus Reynolds, who spent over 2 decades analyzing the chip industry at Goldman Sachs, described the moment with startling clarity. "In my entire career, I've never witnessed anything like this. This isn't just about one company's success. It represents the complete collapse of America's strategy to contain China's technological rise." For years, the United States maintained what appeared to be an impenetrable blockade around cutting-edge chip technology. American companies were strictly forbidden from selling their most sophisticated processors to Chinese customers. Even ASML, the Dutch manufacturer that holds a virtual monopoly on advanced chip-making equipment, was pressured into withholding their critical machinery from Chinese buyers. The message from Washington was crystal clear. China would remain locked out of the bleeding edge of computing power. But in the shadows of these restrictions, Huawei's engineers were orchestrating something remarkable. The unveiling of their Ascend 910C processor didn't just challenge this iron grip, it obliterated it. Rather than simply trying to replicate Western technology, they completely rewrote the rules of high-performance computing. The Ascend 910C represents a radical departure from conventional chip design, ingeniously combining 2 previous generation chips into a single package, effectively doubling both computing power and memory capacity. Dr. Sarah Chen, Director of Emerging Technologies at the Asia Pacific Institute, explained the significance. What Huawei has accomplished goes far beyond clever engineering. They've pioneered an entirely new approach to chip architecture that could fundamentally reshape the future of computing. This isn't just a workaround, it's a revolution in semiconductor design. But every revolution faces obstacles. Huawei's manufacturing partner, Semiconductor Manufacturing International Corporation, SMIC, is currently achieving yields of only 20% on the Ascend 910C, far below the 70% typically needed for commercial viability. Yet, in a display of sheer determination, they're already distributing samples and planning to ramp up production to 100,000 units within the year. The Ascend 910C was just the opening salvo. What came next sent shockwaves through every semiconductor boardroom in the Western world. Researchers at the Chinese Academy of Sciences achieved a breakthrough that industry veterans had long declared technically impossible. They created their own extreme ultraviolet, EUV, lithography system. The holy grail of chip manufacturing that enables production of semiconductors at nodes below 7 nanometers. This achievement strikes at the very heart of Western technological dominance. For years, ASML's monopoly on EUV technology gave the West unprecedented control over who could manufacture the most advanced chips. By developing their own solution, China hasn't just bypassed sanctions. They've blown past one of the last remaining barriers to complete technological independence. The irony is brutal. China currently accounts for over 40% of ASML's global sales. The Dutch government's recent decision to tighten controls on lithography machine exports has only accelerated China's push for self-sufficiency. Chinese companies are racing to secure equipment before restrictions tighten further, while simultaneously developing domestic alternatives. ASML finds itself caught in the crossfire of a technological Cold War, watching its largest market potentially disappear while inadvertently fueling the very competition it was meant to prevent. The impact is already reshaping consumer markets in ways few predicted. Chinese smartphone manufacturer Xiaomi has captured 17% of the Chinese market compared to Apple's 15%. Their flagship devices, powered by these new domestic processors, are delivering equivalent or superior performance at significantly lower prices, directly threatening Apple's premium market dominance. The response from China's tech giants has been swift and massive. Tencent broke a 4-year silence in the markets, with billions poured into AI expansion. Alibaba followed with a staggering $3.2 billion raise through convertible notes and launched over 100 open-source AI models. Baidu joined the fray with 4.4 billion yuan in bonds to accelerate their AI ambitions. James Wilson, chief analyst at Global Tech Insights, captured the scale. The scale of investment we're witnessing is unprecedented. China's AI semiconductor market has exploded to $60.6 billion. Their cloud infrastructure spending has surged to $46 billion. Alibaba Cloud alone has invested $52.4 billion in expanding its AI capabilities. This isn't just growth, it's a technological revolution happening at warp speed. Over $120 billion poured into AI and semiconductor development in just the last quarter alone, a figure that dwarfs comparable Western spending. Dr. Victor Chang, former lead semiconductor analyst at Morgan Stanley, framed the transformation. We're not just witnessing aggressive spending. We're seeing a complete realignment of global technological power. Chinese companies aren't playing catch-up anymore. They're positioning themselves to leapfrog their Western competitors entirely. China's regulatory response has been equally decisive. The Cyberspace Administration implemented a complete ban on Nvidia chip purchases by major Chinese tech companies, creating a vacuum that domestic manufacturers are rushing to fill. The results have been staggering. Local AI chip producer Cambricon reported a mind-boggling 4,400% revenue increase in just 6 months, becoming China's best-performing stock. Even Nvidia's CEO Jensen Huang has been forced to acknowledge the shifting dynamics, recently admitting that China is now nanoseconds behind in the global chip race. The industry giant isn't standing still. They're scrambling to develop new chips specifically for the Chinese market, while simultaneously investing $5 billion in Intel and exploring a massive $100 billion stake in OpenAI's data center development. Dr. Elena Zhang, director of the International Technology Policy Institute, described what's emerging. What we're witnessing is the birth of a parallel technological universe. China is building its own complete ecosystem, from chips to cloud services to consumer devices, that could eventually operate entirely independently of Western technology. This isn't just about catching up anymore, it's about creating an entirely new technological paradigm. The telecommunications sector provides stark evidence of this shift. China aims to triple its 5G base stations to 3.64 million by 2025, while Western telecom giants Nokia and Ericsson have seen their combined market share in China plummet from 12% to a mere 4% in just 4 years. The country's telecom market continues to grow at an impressive 8.74% annually, reshaping the $574.4 billion global 5G infrastructure market. Huawei isn't content with their current breakthrough. The company is already developing 4 new generations of Ascend processors scheduled through 2028. Their latest creation, the Atlas 900A3 SuperPod, connects 384 Ascend 910C processors at a blazing 400 Gbps bandwidth. The upcoming Atlas 950 SuperPod will incorporate over 8,000 neural processing units, representing a quantum leap in AI training capabilities. Dr. Rachel Martinez, Director of AI Systems Architecture at the Global Computing Institute, explained the significance. The Atlas systems aren't just incremental improvements. They represent an entirely new paradigm in large-scale AI computing. The ability to connect hundreds of neural processors at these speeds will enable AI applications we can barely imagine today. Despite the Ascend 910C still relying on some components from TSMC, Samsung, and SK Hynix, China's determination to control its technological narrative is absolute. When Canadian firm Tech Insights published a teardown analysis of the processor, they were swiftly blacklisted from the Chinese market, a clear message about who controls the flow of information about Chinese technology. Michael Thompson, chief strategist at Asia Tech Research, warned, "The next 18 to 24 months will be crucial. As China improves manufacturing yields and expands domestic supply chains, we're likely to see a complete restructuring of global semiconductor manufacturing. Western companies that don't adapt to this new reality risk being left behind." The unified bus protocol, capable of connecting hundreds of neural processors at unprecedented speeds, is evolving into UB 2.0, promising to enable AI systems of staggering scale and complexity. With Huawei projecting shipments of over 800,000 Ascend 910C chips by 2025, scaling to 5 million units annually by 2026, they're positioned to become the world's second-largest AI chip producer after Nvidia. Dr. Amanda Chen, professor of international technology policy at Stanford, captured the broader implications. We're entering an era of technological bipolarity. The question isn't whether China can match Western technology anymore. It's whether the global tech ecosystem can survive this split into two competing spheres of influence. The strategy of technological containment through sanctions and export controls hasn't just failed. It's accelerated China's push for self-sufficiency and spurred innovation in unexpected ways. The emergence of China's indigenous EUV lithography system, breaking ASML's monopoly on this critical technology, stands as testament to the limitations of export controls as a strategic tool. As China's domestic technological ecosystem matures and expands, the very nature of global innovation and competition is being redefined. The next decade will determine whether this technological bifurcation leads to healthy competition and parallel innovation, or a more fundamental rupture in the global technology order. Do you think China will achieve complete technological independence from the West? Drop your thoughts in the comments below, and don't forget to subscribe for more coverage of the global tech revolution that's reshaping our world.